In this lesson, we will study the graphs of the tangent and cotangent functions. To get us started with the tangent function, with the graph of the tangent function, consider these input values rather. We're going to input each one of these values for x as the input, and then generate the function value, the output. Now notice that the input values range from negative pi over 2 all the way to positive pi over 2. The tangent function is undefined for odd multiples of pi over 2. So at negative pi over 2, it's undefined. At positive pi over 2, it's also undefined. So at these two values, you have vertical asymptotes. At negative pi over 2 and positive pi over 2, you're going to have vertical asymptotes because the function is undefined at those locations. So I have the graph going here, and notice my vertical asymptotes at both pi over 2 and negative pi over 2. And so when we plot these points, at pi over 4, positive pi over 4, we're at 1, and at 0, we're at 0. So it goes right through the origin here. And negative pi over 4, you're at negative 1. Now we know that the graphs of functions must get infinitely close to these asymptotes, so the graph has no choice but to behave like this. Now there's a few things I want us to notice about the graph of the tangent function. Let's summarize some observations now. The first thing I would like us to remember is that the domain for the tangent function is a set of all x values such that x cannot be any odd multiple of pi over 2. Now, the way we wrote this down in earlier studies is the set of all x, this is set builder notation by the way, the set of all x such that x is not an odd multiple of pi over 2. Remember that n here represents any integer. Okay, this is how we say x must not be, the input value must not be any odd multiple of pi over 2. At those locations, at odd multiples of pi over 2, that's where you have vertical asymptotes. Now, the range, we talked about this in an earlier lesson. The range is all real numbers in interval notation. That'll be from negative infinity to positive infinity. Now, the graph is discontinuous. It's discontinuous at every odd multiple of pi over 2. That's where it's discontinuous. So I'm going to say at x equal to any odd multiple of pi over 2, that's where you have a vertical asymptote. That's where, if you were drawing this curve here, right, if you were drawing this curve, you would have to pick up your pencil, right, to get to the next branch, right, because you would have this vertical asymptote here. So this is a point of discontinuity, right? All right, x-intercepts, notice that you have an x-intercept at 0 here. The next x-intercept will be at 1 pi. It would be over here. Or at negative pi all the way to the left over there. In other words, the tangent function will have x-intercepts of the form n pi, any multiple of pi, any multiple of pi. Now remember that n stands for any integer. Notice that now this is very important, what we're about to say next. The period is pi, from negative pi over 2 to positive pi over 2. That distance there is pi. You know, the period for sine and cosine is 2 pi. Well, the most basic period for tangent, and we're going to find the same is true for cotangent, is pi. So make sure you let that sink in, right? Make sure you have that in your notes very clearly, that you get all of the function values over the period of pi, okay? Now, this is very important because the graph of the tangent goes infinitely high and infinitely low. There is no maximum and there is no minimum, so that's very important. The graph is symmetric with respect to the origin, right? Just like the sine function, it's symmetric with respect to the origin, so it is an odd function. That means tangent of negative x will be equal to negative tangent of x. That is, if you negate your input, you will negate your output. Now for the cotangent function, I have some input values already considered here. Notice that the input values range from 0 all the way to pi. That is because we know from the domain of cotangent that it will be undefined. Cotangent will be undefined at any multiple of pi. So at 0, it'll be undefined, and at pi, it'll be undefined. You'll have vertical asymptotes at 0 and at pi. All right, so I have that the cotangent function is undefined at 0 pi and also at 1 pi. And I have all of these function values here for cotangent. Let's graph the function. All right, I have my vertical asymptotes already drawn at 0 pi and at 1 pi. And at pi over 2, you have an x-intercept. It's 0 there. And at pi over 4, which is right here, this is pi over 4, which is halfway between 0 pi and pi over 2, you are at 1. So let me plot that for us. At 3 pi over 4, which is right here, right in the middle of pi over 2 and pi, you are at -1. So let me plot that as well. So the graph has this shape here, very similar to tangent. It has this shape here. This is the shape of the most basic cotangent function. All right, let's write down some observations. First, the domain. The domain is a set of all x such that x is not any multiple of pi. That's how we write that in interval notation. The range is all real numbers. It's discontinuous at any value of x that is a multiple of pi. This is where the vertical asymptotes will be, by the way, at any multiple of pi. The x-intercepts here are of the following form. They will be any odd multiple of pi over 2. Let me show you that on the graph. Here is an odd multiple of pi over 2. This is an x-intercept. The next odd multiple of pi over 2 would be 3 pi over 2, and that would be the next intercept. -1 pi over 2, -1 pi over 2, which would be way over here on the left side of the graph, you'd have another x-intercept there. Notice that just like tangent, the period is pi. From 0 to pi, you get one complete branch. Also, just like tangent, there is no maximum, there is no minimum. And it is symmetric with respect to the origin, so it is an odd function, so cotangent of -x is equal to negative cotangent of x. That is to say, if you negate the input, the output will be negated as well. All right, for our first example here, we're going to graph y is equal to tangent of 2x. Now, notice that this, as a transformation here, this is a horizontal shrinking. This is a horizontal shrink. So think about your tangent curve, the most basic tangent curve that you and I graphed a minute ago, and imagine that being horizontally shrunk. Okay, the first thing we're going to do is find the period. Now, remember the period is pi, so the period here will always be pi over b, pi over b. Now, if you will remember that for sine and cosine, it was 2 pi over b, but for tangent and for cotangent, by the way, it'll be pi over b. In this example, your b value, which is the coefficient of your argument x, is 2. So your period is pi over 2. That makes sense to what we just said a second ago, that this was going to be a horizontal shrink. So instead of the period being pi, it's now shorter than that. It's pi over 2. So this makes sense. Now what I want to do first, or what I want to do next, I guess, is locate the two vertical asymptotes. Locate the two vertical asymptotes. Now remember, this is a tangent function. So what I'm going to do is, in order to find the two vertical asymptotes, I am going to take my entire argument and set it equal to negative pi over 2. And I'm going to take my entire argument and set it to positive pi over 2. Now the reason why I'm setting my argument to negative pi over 2 and positive pi over 2, because this is the tangent function. And the most basic, now listen to this, the most basic tangent function has vertical asymptotes at negative pi over 2 and positive pi over 2. Remember that the tangent function is undefined at any odd multiple of pi over 2. So once this entire argument takes on any value that is an odd multiple of pi over 2, the function is undefined. So that's the reason why I'm setting this equal to negative pi over 2 and positive pi over 2. To solve for x for each of these, the first one you're going to want to multiply both sides by 1/2. So you're going to see me do that. I'm going to multiply this by positive 1/2. And you're going to see that x is equal to negative pi over 4. Solving this equation for x, I'm going to do the same thing. Multiply both sides by 1/2. And you get x is equal to positive pi over 4. Now, pay close attention here. These are your two vertical asymptotes. The function is undefined at both pi over 4 and negative pi over 4. Now, what this does for us, in addition to us finding our vertical asymptotes, is this gives us now the interval over which the function will complete one period. So the interval is from negative pi over 4 to positive pi over 4. That's the interval, all right, that we're going to show where this function completes one period. Now, please notice that this interval here has parentheses, not brackets. The reason why these are parentheses is because both at negative pi over 4 and positive pi over 4, the function is undefined. So these two values, which are your left endpoint and your right endpoint, these two input values, the function would be undefined here. Okay, so what we're going to do is very similar to what we did in earlier lessons for sine and cosine. We're going to take this interval and split it into equal parts in order to find those key x values. All right, let's do it. So we're going to find the midpoint first. So what we're going to do is find half the sum of the left endpoint and the right endpoint. And this is just going to be half of 0, which is just 0. So 0 is your midpoint, all right? The first quarter point is going to be found by taking half of the sum of the left endpoint and your midpoint that you just found. So then this is half of negative pi over 4, which is negative pi over 8. That's your first quarter point. Your, I labeled this quarter point 2, but it's really quarter point 3 because remember that your midpoint is really your second quarter point. So the third quarter point will be found by taking half of, and if I just stay consistent here with my colors, half of the sum of the midpoint and the right endpoint. So then this is just half of pi over 4. Which is positive pi over 8. All right, I have my table of values ready to go. When I plug in the left endpoint, negative pi over 4, and when I plug in the the right endpoint, which is positive pi over 4, do not forget, please, that these are where your vertical asymptotes are, that we already figured that out. So really, for tangent and cotangent, there's only going to be three input values that you're considering, basically your midpoint and your two quarter points. Because the left endpoint and the right endpoint of your intervals will always be your vertical asymptotes. So you'll always have undefined values over here for the left endpoint and the right endpoint. So there's always these 3 points that you're finding. The first quarter point, the midpoint, and the third quarter point. All right, so let's do it. When we plug in negative pi over 8, right here, 2 times negative pi over 8, you can do this arithmetic, you will find that 2 times negative pi over 8 is negative pi over 4. And tangent of negative pi over 4 is negative 1. 0 would be easy arithmetic because 2 times 0 is 0, and tangent of 0 is 0. Pi over 8 is next. When you plug in pi over 8 right here, 2 times pi over 8 is pi over 4, and tangent of pi over 4 is positive 1. So there we have it. Let's go to the graph now, the Cartesian plane. All right, here's the graph. It looks so similar to the most basic tangent function. The main difference, though, is that instead of you getting the whole graph between negative pi over 2 and positive pi over 2, it's a shorter period. It's from negative pi over 4 to positive pi over 4. Again, that agrees with that horizontal shrinking that we mentioned. All right, good job, everybody. So there's the graph. Let's do another example. All right, we have y equals negative 3 times tangent of 1/2 x. All right, let's find the period. Notice that the period will be longer than usual because this is a horizontal stretch. Okay, the period will be pi over b. Now remember that your b value here is the coefficient of x, so it'll be 1/2. So with some arithmetic, you know that this is pi times 2, right, which is a reciprocal of 1/2. So your period is 2 pi. Now that's not like the most basic tangent function. The most basic tangent function has a period of pi. And so this is now longer than usual, which makes sense because we said it was going to be a horizontal stretch. Now, in order to figure out the interval over which it completes this period, I need to find the vertical asymptotes first. So let's find the vertical asymptotes, and then we can come back and say what our interval is. So to find the vertical asymptotes, I'm taking my entire argument and setting it equal to both negative pi over 2 and positive pi over 2. Now, the reason why I'm setting this function equal to both negative pi over 2 and positive pi over 2 is because that's where the vertical asymptotes are located for the most basic tangent function. Again, the most basic tangent function is undefined for any odd multiple of pi over 2. So that's why I'm setting it equal to negative pi over 2 and positive pi over 2. Now the way I'm going to solve for x for each of these is by multiplying both sides by 2. So you're going to see me do that now. And you get here that x is equal to negative pi. There's one vertical asymptote. The other one will be located whenever pi over 2 is multiplied here by 2, and you get x equal to pi. So these are your two vertical asymptotes, right? These are the two locations where the function is undefined. Now, this gives us that interval that we were interested in finding, right? The interval over which it completes one period. And so that interval is from negative pi to positive pi. Remember to put parentheses and not brackets because you're undefined at these two endpoints. Those are your vertical asymptotes. Now it's time to take this interval and split it into equal parts. In other words, find that midpoint and your quarter points. All right, in order to find the midpoint, you're probably, really used to doing this now. We take half of the sum of the endpoints. So this will be half of 0, which we know to be 0. There's the midpoint. The first quarter point will be half of the sum of the left endpoint and that midpoint you just found. So it'll be half of negative pi. That's a little sloppy. Let me rewrite that. Half of negative pi, which is negative pi over 2. Now, to find the third quarter point, I did it again, folks. This is supposed to be called quarter point number 3. Again, the reason is because the midpoint is technically your second quarter point. So anyway, going back, the third quarter point is half of the sum of the midpoint and the right endpoint. So it'll be half of pi, which we know to be pi over 2. So we found those three. It's really now, if you count the endpoints, it's 1, 2, 3, 4, 5. 5 input values that are going to be really key for us. However, these endpoints, remember, these are the vertical asymptotes or where the vertical asymptotes are located. So remember, these are undefined values. So these are really the input values that we really want. All right, remember that at negative pi, we're undefined. That's a vertical asymptote, again, at pi. All right, I'm going to plug in 0. It's probably the easiest math to do. 1/2 times 0 is 0. Tangent of 0 is 0. And negative 3 times 0 is 0. And so that's a 0 there. All right, let's plug in negative pi over 2. Half of negative pi over 2 is negative pi over 4. Tangent of negative pi over 4 is negative 1. Negative 3 times negative 1 is positive 3. Next is positive pi over 2. Half of positive pi over 2 is pi over 4. Tangent of pi over 4 is positive 1. Negative 3 times positive 1 is negative 3. All right, here's the graph. It looks very similar to the tangent function, but notice that it did get reflected, right? It get reflected across the x-axis because of this negative sign here. It did get vertically stretched by a factor of 3, and it did get horizontally stretched. All right, that's all of the transformations here. Good job, you guys. All right, now we have y is equal to 3 times cotangent of 1/2 x. Now, pay close attention that the function just changed. It's no longer tangent, it's cotangent. Now, first things first, period. The period is pi over b, just like tangent. And in this case, it's pi over 1/2. So the period is 2 pi. Now the vertical asymptotes, now pay close attention here. The most basic cotangent function has vertical asymptotes located at every multiple of pi. Cotangent has vertical asymptotes at every multiple of pi. Therefore, I'm going to take my whole argument, set it equal to 0, and set it equal to pi. Because whenever this argument is 0, the whole argument is 0, or whenever the whole argument is pi, cotangent will be undefined, which means there will be a vertical asymptote there. So notice that in order to find the vertical asymptotes for the tangent function, we were setting the argument equal to negative pi over 2 and positive pi over 2. Now, because it's cotangent, we're setting it equal to 0 and pi to find those vertical asymptotes. Multiply both sides by 2, and you're still going to have x equal to 0. Multiply both sides by 2, and you'll get x is equal to 2 pi. Ladies and gentlemen, these are your two vertical asymptotes. Okay. Now, because this is a horizontal stretch, normally your vertical asymptotes are at x equal to 0 and x equal to pi. But now they're at x equal to 0 and x equal to 2 pi. So this whole interval has been stretched horizontally, which agrees with what this notation is here. Okay, now we know what the interval is. The interval is, instead of 0 to pi, it is 0 to 2 pi. This is the interval that we are splitting. All right, let's find our midpoint. We're going to take half of, I think maybe you can do this without showing the arithmetic. Right in the middle of 0 and 2 pi, I mean, look at a picture here. Look at your unit circle. Right, look at your unit circle. And here's 0, and here is 2 pi. What's right in the middle of 0 and 2 pi is pi, right? And so I hope that suffices. We know that the midpoint is pi. Now you can do the arithmetic where you take half of the sum of 0 and 2 pi, and like we have been, and you're going to find the midpoint is pi. The first quarter point is going to be right in the middle of your left endpoint, which is 0, and the midpoint, which is pi, which is pi over 2 is right in the middle. This is your first quarter point, pi over 2. Again, you can show the arithmetic like we've been doing. Your third quarter point will be right in the middle of your midpoint and 2 pi, which is your endpoint. And what's right in the middle between here is 3 pi over 2, which is right there. So 3 pi over 2 is your third quarter point. Again, you can do half of the sum of the endpoints of that interval like we have been, and you will have found the same quarter points and the same midpoint. All right, we have our input values here. Don't forget your vertical asymptotes at both the left and right endpoints. When you plug in pi, half of pi is pi over 2, and cotangent of pi over 2 is 0. 3 times 0 is 0. So you have an x-intercept there. When you plug in pi over 2, half of pi over 2 is pi over 4. Cotangent of pi over 4 is 1. And 3 times 1 is 3. And here, we should get negative 3, right? 3 pi over 2. Half of 3 pi over 2 is 3 pi over 4. And cotangent of 3 pi over 4, that's quadrant 2. That'll be negative 1. 3 times negative 1 is negative 3. Cool. And this is what we have when we plot those points. Awesome. Good job. Let's do a couple more. All right, next we have y is equal to 2 plus tangent of x. I want you to notice something right away. The argument is just x. There is no horizontal transformation here. There is no phase shift. There's no horizontal stretching. There is no horizontal shrinking. So the period is not going to change. The period is going to be the same as the period of the most basic tangent function. What also is not going to change is the location of your vertical asymptotes. The location of the vertical asymptotes will be the same as the most basic tangent function, again, because there is no horizontal transformation. So the period will just be pi over b, but notice b is just 1. That's the coefficient of x. And so the period is just pi, just like normal, right? So that has not changed. That's not different. The vertical asymptotes, you take your, because this is the tangent function, take your argument, set it equal to negative pi over 2. Take your argument and set it equal to positive pi over 2. So we already knew that these would be the vertical asymptotes because this is where your vertical asymptotes are normally located and there is no horizontal transformation, so that's still where they're located. The interval then that we are splitting is negative pi over 2 to positive pi over 2. So the transformation, the only transformation I see is this one right here, the plus 2 here, which is a vertical translation up 2 units. All right, we found the midpoint to be 0, the first quarter point to be negative pi over 4, and the third quarter point to be positive pi over 4. We're going to go ahead and plug in these values now. All right, we went ahead and plugged in these values. Notice that that you have to add 2 to your result, right? For example, for negative pi over 4, tangent of negative pi over 4 is negative 1. 2 plus negative 1 is 1. That's how I got that. 0, tangent of 0 is 0, but 2 plus 0 is 2. So that's how we're doing each one of those. Let's go ahead and plot this. So here we have 0, 2. Here we have pi over 4, 3. And here we have negative pi over 4, positive 1. So when we graph this curve, it looks something like this, which is just like the regular tangent curve, but just moved up 2 units. So two units higher. Cool deal. All right, graph y equal to negative 2 minus cotangent of x minus pi over 4. Now let's locate all of, or identify all of the transformations. This is a phase shift pi over 4 units to the right. This negative here is a reflection across the x-axis. This negative 2 here is a vertical translation 2 units downward. So there's a lot going on. All right, notice that for the period, notice that the coefficient of x is just 1. So the period is just pi over b, which is pi over 1, which is just pi. That's the normal period for cotangent. So there is no horizontal shrinking, no horizontal stretching. There is a phase shift, but there's no horizontal stretching and no horizontal shrinking. So the period does not change. To find the vertical asymptotes, I take my entire argument, and because this is the cotangent function, I'm setting that equal to 0 and to pi, and then solve for x. So I'm getting that a vertical asymptote is located at x equal to positive pi over 4, and I'm getting that x, there's another vertical asymptote at 3 pi over 4. Excuse me, not 3 pi over 4, 5 pi over 4. Remember that pi is really 4 pi over 4, so when you add one more pi over 4, you get 5 pi over 4. So let's be careful with our arithmetic there. 5 pi over 4. Okay, great. So these are your vertical asymptotes, all right? Your vertical asymptotes are usually at 0 and pi for cotangent, but both of these vertical asymptotes are a little bit to the right. Right, shifted over to the right, which is why we called out that phase shift earlier of a horizontal translation, a phase shift, pi over 4 units to the right. The interval over which this function completes a period is from pi over 4 to 5 pi over 4. So now let's find the midpoint and those quarter points. All right, we found our midpoint to be 3 pi over 4, our first quarter point pi over 2, and our third quarter point pi. All right, we went ahead and plugged in these values, and we got -3, -2, and -1. All right. So let's go ahead and plot these and see what the curve looks like. All right, we're going to go ahead and draw our vertical asymptotes at pi/4 and at 5 pi/4. And then we have some function values here. At pi/2, we're at -3. At 3 pi/4, we're at -2. And at pi, we're at -1. And then we can connect these points like this. And here is our graph showing one period. All right, cool deal. Great job, everybody. All right, this is the end of this lesson. I hope you learned a lot about the tangent and the cotangent functions. I'll catch you in the next lesson. See ya.